this thing on? Oh yeah, it is. Graphing inverses. So basic notes, you're going to generate a table of your original function, whatever your original function is, and then once you have that table, we're going to swap all the x and y values completely. So you see this quick little example here. Here's some original function, f of x equals 3x with table values, and then this is the inverse function already solved, but more importantly, look at the table values, where we had originally -2, -6, now we have -6, -2, and so on for all of these. Any x and y pair just swapped throughout the whole table. That's the important thing. When you're graphing the inverse, you swap the x's and y's. So then using the new table, you just graph the inverse. And keep in mind that sometimes the inverse is not a function. So let's do that with this one here. Let's generate a table for my function, and I'll just use some pretty basic values. We'll go with -4, -2, 0, 2, and 4. I chose those because I know those are going to work out nice. So if I plug in -4, half of -4 is -2, -2 minus 4 is -6. Just keep this going. Half of -2 is -1. -1 minus 4 is -5. And plugging in 0 would be -4. And if you notice the pattern, this just seems to be increasing by 1 each time. Okay. So then this is my regular function table, and I can graph that. I've got these here. Okay, okay, and okay. So that's my function. Okay. Now to graph the inverse of this, I'm going to use a different color. I'm going to switch the table. So then now I'm going to have -6, -4, -5, -2, -4, 0, -3, 2, and -2, 4. So here we go. -6, -4, -5, -2, -4, 0, -3, 2, and -2, 4. Which will look like this. And lo and behold, I've graphed the inverse. One thing that is worth mentioning is that the inverse will always be a line of reflection across the line y equals x. So I just kind of very crudely drew in y equals x right there, the yellow line, and you can see that the blue line is a reflection of the red line across the yellow line. So if you just imagine a little diagonal line, y equals x right here, then the inverse is always the reflection across that line. Alright, so let's do the same thing, but this time let's do it with a quadratic. X squared minus 4. So I'm going to go with -2, -1, 0, 1, and 2. And I know -4 is going to be the vertex, just because I'm pretty smart like that. And then I know, using my basic quadratic stuff, it's going to go up 1 here and here. So that's -3 here and here. And then I know it's going to go here and here. So those are going to be zeros. So anyway, however you do it, either using your calculator or using, by hand calculations, whatever, come up with your table, and then now, of course, graph that, then swap the x's and y's. Okay, so we do that, then I'm going to have 0, -2, 3, negative 1, negative 4, 0, negative 3, 1, and 0, 2. So I graph all that. 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3 again, but at positive 1 this time, and 0 again, but at positive 2. Now you might notice that this blue curve fails the vertical line test. That's because the full inverse of a quadratic is not a function, and we'll talk more about that in the next video. But when you just use the table, this is what it would look like. And once again, I can just real quickly prove that if I draw the dashed line here, I can see that the blue and the red are still reflections of each other. And then lastly on this one, let's draw a table, x's and y's. Let's see, I'm pretty sure I know that the vertex is at, I want to say the vertex is at negative 3. Let me factor this. This would factor into x plus 3 squared. So then that does mean that negative 3 is a 0, and I already know that's going to be the vertex. Alright, so then I'm going to go with the numbers that are around that. Negative 4, negative 5, negative 2, negative 1. Now how would you know how to choose these things? If you're looking at a table, just especially if it's quadratic, it should be centered around the vertex. So find where the vertex is in the table and choose points around that. If it's linear, it really doesn't matter. Just go with some points that give you nice easy numbers. But quadratic, it should be centered around the vertex. Alright, so once again, using my simple knowledge of quadratics, I know it's going to go up 1 here. It's going to go up a total of 3 more, so it will be at 4. Okay. And so then at negative 3, 0, I've got a point, and then here, here, and there. Okay. And switch the table. I have 4, negative 5, 1, negative 4, 0, negative 3, 1, negative 2, and 4, negative 1. So, starting again with where the vertex, if you want to call it that, the vertex for this thing would be at 0, negative 3. Let's see, the other points we've got 1, negative 4, and 1, negative 2. And then at 4, negative 5, and 4, negative 1. Alright, and then one last time, just showing that this whole thing is a reflection. You can clearly see how the red is a reflection of the blue there. And that's just a quick little visual test that you can always check as well. So that is graphing by inverses. Again, the main idea is just, however necessary, generate the table of your original function, either using calculator or whatever. Once you have that table, if you switch all of those x's and y's, then you use that new table to create that. Ah! The bell just rang. That sucked. Okay. Well, I think that was it. So, rewatch anything you need to, take notes, write summaries, you know the drill.